Hello there, Mr. Sutton here, bringing you the AB Calculus Derivative Extra Practice number 4 solutions. For this derivative, we need to use the product rule. So we've got u prime v plus uv prime, and here's the box and ribbon to help us out. We have factors of x squared and ln of x, and derivatives of 2x, and then ln of x is going to be 1 over x. Using the ribbon to put that together, we've got 2x ln of x, plus, and now we're going to have x squared over x, which we can just simplify to x. For this one, we're going to use the product rule, u prime v plus uv prime, to take this derivative. So box and ribbon time, we have factors of x cubed and arcsecant of 3x. Derivative of x cubed, that's going to be 3x squared. And for arcsecant of 3x, we need the chain rule. So derivative of arcsecant of something is going to be 1 over the absolute value of something times the square root of something squared minus 1. So that's going to be 1 over absolute value of 3x, and then 3x squared minus 1 inside a square root. But don't forget to multiply by the derivative of 3x, which is 3. All right, using the ribbon to put it back together, we've got 3x squared arcsecant of 3x, plus, now we're going to have a 3 and an x cubed on top here, and all that other stuff in the denominator. To take the derivative of this function, before we actually use the quotient rule here, we could actually do this one by simplifying first. So I'm going to divide each of these by e to the 2x. So e to the x over e to the 2x, we're subtracting the exponents. That's going to be e to the negative 1x. And then this is going to be minus e to the negative 3x if I divide. So now I can just use the exponential rule. This first one, we're going to have e to the negative x times a tail of negative 1. So that's negative e to the negative x. And then for this one, we have negative e to the negative 3x times a tail of negative 3. So that actually ends up being plus 3 e to the negative 3x. And this one's done. For this one, we're trying to take the derivative of ln of this quotient. Now, before you do a quotient rule inside a chain rule, let's first see if we can simplify this a little bit using log rules. So ln, when you take the ln of a quotient, you're actually subtracting the individual logarithms of the things involved. So this is going to be ln of 4 to the x minus ln of 3 minus ln of sine of x. You actually subtract the ln of each thing that you're dividing by. And just simplifying a little bit here, we can pop out this x in the first term. So that's really x ln of 4. All right, let's take these derivatives now. This is going to be a little bit nicer. We have x times ln of 4. Ln of 4 is a constant. Whenever you have the derivative of x times a constant, you're just getting the constant. So this just ends up being ln of 4. Ln of 3 is a constant, so that's just 0 if we take that derivative. And over here, we've got a chain rule. This is minus ln of something. Well, that's going to be minus 1 over the something, 1 over sine. But now we need to multiply by the derivative of sine, which is cosine. For this problem, we can make our lives a little bit easier if we simplify. Arcsine of sine is just going to be canceling out, giving us x as that exponent. And now the derivative of e to the x, that's just going to be e to the x times ln of the base, ln of 8. To grapple with this derivative, I'm going to first rewrite this middle term as 6x all raised to the 1/2 power. So now I can use the power rule on that. And now just going left to right, it looks like I have a few power rules here. X cubed, that's really going to be 3x squared. And I'm going to need a chain rule on this as well in the middle here. This is really something to the 1/2 power. So that's going to be minus 1/2 something to the negative 1/2. The something being 6x. But now we have to multiply by the derivative of 6x, which is 6. For this problem, we are going to use the product rule, u prime v plus uv prime. Here's the box and ribbon to help us sort this out. We've got our factors, x plus 2 quantity cubed, and x squared minus 6x quantity to the 5th power. The derivatives of these are both going to require chain rules. For this first one, we have something cubed. That derivative is going to be 3 times the something, x plus 2 squared, times a tail of 1. So actually, it is a chain rule, but it isn't really a significant chain rule with that invisible 1. And then over here, this is going to be a little bit more of a chain rule. So this is something to the 5th power. The derivative of that is going to be 5 times the something, x squared minus 6 to the 4th. But now we have an actual tail to multiply by. This is going to be 2x minus 6 for that derivative. And now we're going to put it all together using the ribbon. So we've got 3 parentheses x plus 2 squared times x squared minus 6x to the 5th. That's the u prime v part of this. Plus, we have x plus 2 cubed times all of this stuff down here. This problem's kind of a cute one. We have sine of x to the sine of x power. So because I have a variable in both the base and the exponent, for the derivative, I'm going to need to use logarithmic differentiation. So I'll start by taking the ln of both sides of this equation to get this sine of x out of the exponent. On the left side, I've got ln of x. And doing the ln on the right side, that pops this exponential sign out. So now it's on the ground, so to speak. And then we have ln of the base sine of x there. So now we're going to implicitly differentiate, treating y as an inner function with its own tail. So over here, derivative of ln of y, we've got 1 over y times dy over dx, because again, we have an inner function of y that's a function of x. On the right side, we need to use the product rule. So I have my 2 factors, sine of x, and I also have ln of sine of x. Derivatives of those are going to be cosine of x, and this is going to be a chain rule here. This is going to be 1 over sine of x times the derivative of sine, which is cosine. So you could call that tan, but you'll see in a minute there's no reason to. Multiplying that back out now with the ribbon, we have cosine of x, ln sine of x. And then we're going to be adding to that, well, sine of x and 1 over sine of x are going to cancel. I mean, I'm all for not simplifying when I don't need to, but that's an easy one. So this is really just going to be plus cosine of x. And at this point, we still need to isolate dy over dx. We can do that by multiplying both sides by y. So I'm going to have all the stuff on the right side in a big parentheses with the y that I just multiplied outside. And they never said we had to put it just in terms of x. But if you wanted to, you could replace this y with sine of x to the sine of x to get this final answer. For this derivative, since we can't isolate y first, we're going to have to implicitly differentiate, treating y as an implicit function of x. So whenever we take the derivative of something with a y on this one, we're going to multiply by a tail of dy over dx. So going left to right here, we have a little bit of a chain rule anyway with this first term. This is something squared. The derivative of that is going to be 2 times the something to the first. So 2 times cosecant of y. But now we have to multiply by the cosecant of y's derivative. That's going to be negative cosecant of y cotan of y. And then we have to multiply by the derivative of y, which is dy over dx. All right, so the next one we have minus, using the power rule, we have minus 153 x squared. And over here on the other side, this is going to be 8 dy over dx. Now at this point in the game, we're going to get all of the dy over dx's over to the left side, everything else over to the right side. So this 2 cosecant of y business here, all this first term can stay where it is. The 8 dy over dx, I've got to subtract that to get it over here. And let me add my 153x squared to get it to the other side. Now I can factor out a dy over dx on the left side, leaving me with 2 times all of this craziness, minus 8, inside the parentheses. And then finally, we can just divide by this big parentheses to get dy over dx by itself. So this ends up being our final answer. On this problem, they want to know if you know the difference between power rule and exponential derivative rules. This first term, pi to the x, that's an exponential. So that derivative is just going to be pi to the x times ln of the base, ln of pi. For this next one, x to the pi, that's actually a power rule because we have a variable to a constant. Pi is a constant. So this one is going to be minus pi x to the pi minus 1. To take the derivative on this one, it would probably be a good idea to simplify before we do anything else. Otherwise, we're in for a little bit of a product and a chain rule for this one. Secant squared of x, we know that's equivalent to 1 over cosine squared of x. So that means that 2 of these cosines and 2 of these cosines can cancel, leaving us with just y equals cosine of x. Well, the derivative of cosine of x, because we haven't actually taken a derivative yet, that derivative is just negative sine of x. So that's it.